And there it goes. Hi, my name is Brian McClendon, and I'm in charge of Google Maps, Earth, and Street View, and the other Google Geo products. And I'd like to welcome you here today to talk about what's new in Google Maps. But to start with, I need to talk about some history. Hic sunt draconis. This is what they wrote on old maps when they were drawing them and they didn't know where the borders were. It was to tell the people looking at the maps, don't go there, you might fall over the cliff. But our goal at Google has been to try to remove as many of dragons from your maps as possible and make it possible for both our billion users and all of the developers to have as few dragons as possible. To do this, we go forward. The three principles of Google Maps are comprehensiveness, accuracy, and usability. And this is what we do whenever we think about what projects we're going to work on and how we're going to improve our data and our user experience. So the first is comprehensiveness. Google has been working on crawling the web for years. And as they were crawling the web, they were getting more and more data. In Maps and Geo here, we were collecting as much data as we possibly could. And so comprehensiveness and completeness has always been part of the product. But in the early days, we started here. This is the first Google Maps in 2005. And it was really a revelation of the time because before then, you saw that map providers would, when an offline request, they would render a map, and it would take 10 seconds. You'd go pan and zoom, and be another 10 seconds. You'd have to wait. It was good at the time. The internet was an amazing thing to have maps, but we thought we could do better. And so we invented several things to make Google Maps in 2005. The biggest one was we decided to pre-render the map. We took all of the map data for the world and baked it into map tiles, many of which you're very familiar with, and set it up so that we could serve them very, very quickly. And this changed the interaction model for user maps. The dragging and zoom was very fast. We also simplified the search box up there. The single search box was much better than the 2, 3, or 6 entry search box from the past. So getting this product was amazing, but it was limiting. So this was our first actual world map in 2005. And you'll notice that's not a mistake, that we actually didn't have Western Europe. We didn't have Central and South America or pretty much anywhere else in the world. There were, in fact, dragons on our map in that first launch. And we spent time improving the map. And by 2007, we had basically the whole world covered, but there were still skeletal holes, countries where we had the basics, but we didn't have in-depth data. However, by 2008, we did have licensed data for the entire world, and we were able to show a good world map. But it was just the beginning. Here we go. Imagery. Coming from Keyhole, we were acquired by Google in 2005. Our goal was to get as much satellite and aerial imagery as possible. And we worked on that project at Keyhole for many years, pushing hard drives around. When we got to Google, they gave us 1,000 servers, and we started. Larry signed a check for digital globe data, and suddenly we had a large amount of satellite. We were very excited about what we'd achieved from the launch of Google Earth in 2005 to 2006. And we had covered 37% of the world's population with high-res imagery. That was great, but there's a long way from there to making everybody happy, because the main question everybody asked when they would look at Google Maps and Google Earth was, can I see my house? And the goal in 2012, we now have over 5 billion people who can say the answer yes to that question. And today, every 2 weeks, we push as much data as the entire database was in 2006. Another project, Street View, started in 2007. We published 5 cities with this panorama imagery, about 4.5 megapixel panoramas. And it was a great hit. Everybody loved this virtual tourism. They would jump in and drive down the street, and it was very exciting, but it was just the beginning. And we took this project and greatly expanded it. By 2012, we have 39 countries, 3,000 cities plus. We've driven over 5 million unique miles. We now have data in all 7 continents. The 7th one was added in Antarctica by me in 2010. And so I actually went and took these pictures with a standard camera with a fisheye lens and gave it to the Street View team. And they added Half Moon Island on the Antarctic Peninsula. But we're just started there. We actually have some good handle on getting even more Street View data in Antarctica. So that's pretty cool. However, that project, while grand in scope and has taken a lot of our time, led us to think of something even bigger, which was to build our own maps. In 2008, we were somewhat dissatisfied with the data that we were able to license. It was not as accurate as we liked, and we couldn't update it very quickly, sometimes taking three months to a year to get updates through the system. And so we started embarking on creating our own map data using government data, any data that we could license in and bring in to make part of our own maps, but basing it on Street View and the power of having ground level checks on a lot of this location data. We called the project Ground Truth, and this is an example. This is a screenshot of our internal tool to make the maps. And you can see we combined Street View GPS tracks, we combined Street View imagery, we took road data, we took the orthographic imagery that we had from all over the place, and we used computer vision to extract data from Street View. So you can see pictures here of like the 101 sign, also a speed limit sign down there in the bottom right. We would actually extract those and show those to operators so they could improve the attributes and correct and detect issues as we were going through and making our own map data. And this led to incredibly high quality maps that we launched initially in the United States in 2009. In parallel, we used MapMaker. So GT was a great story for the developed world where we had Street View data and so on, but there's a lot of the maps that were completely blank. As you saw at the beginning of this video in 2008, there was nothing in Faisalabad, Pakistan. And over 4 years, they've taken a blank map and turned it into one of the best maps, of any city that I know of. This is all with local knowledge and people who are passionate about making maps. And MapMaker has allowed people all over the world to add and improve data and add to the comprehensiveness of Google Maps. And so the countries like Pakistan, Romania, Vietnam, Philippines, by far the best maps anybody's ever had are currently in MapMaker. So, 2008, we were licensed data. Today in 2012, we have 187 countries with driving directions, which is sort of our min bar for claiming that we have good data coverage. 26 million miles of navigable roads. You can see the contributions of Google-sourced imagery, Google-sourced data, and the user data, along with still some countries that we do license. Accuracy. Making that data useful and correct has been a challenge for us. There's a lot of ways to introduce error and a lot of ways to fix them. My philosophy in building maps at Google has been that combining all this data together and figuring out how to make it improve each other is the critical part. So if you look at this here, we have terrain data that we get. We actually generate it from imagery at times. We have map data. We have Street View. We have the GPS tracks from Street View, the imagery from Street View. We have the orthographic imagery, and now this 3D imagery that Peter will talk about, all combined. And if you think about it as a collection of semi-accurate data, you can use the different layers to correct each other. You can find out how the roads align with the imagery, how the terrain aligns with the roads. You can see how the 3D building data aligns with the road data, so the overpasses, are they in exactly the right place? All of this leads to a much more accurate map. And on top of that, we have our local data, the local businesses and POIs, and the ability to correctly place those across the map makes us a much better map story, but we're still working on it because there's so many different things we can do. As an example, here's Street View. Here's some of the stuff that we do both manually and automatically. Computer vision is able to pick out street signs and business names, also pick out speed limits, detect whether it's a bicycle lane or not. And what computer vision can't do, it can provide data to our operators to continue to improve the map. But there's other ways to do it. We use our users. Report a problem is very popular in both desktop Google Maps and GMM. If a user sees a problem, they don't like a direction they're given because they pretty much know that it's wrong, they can report it and send it to us. We then take that report to our operators who use this very customized back-end tool that has much more access to our database and can look to see not only what our data shows on the public map, but all of our internal data structures with a very high-quality Street View navigator that allows the user to very quickly compare what the user said to what we see in Street View. So if it matches in that way, we're done. It's easy. But if it doesn't match, we'll go and investigate further using whatever means possible. And the result is we get a much more high-quality map. But there's some reports we can't do anything with. MapMaker is launched in 10 new countries in the month of June. So we're also using MapMaker to improve our high-quality developed world maps. And so, people can add hiking trails, biking trails, and make the same kind of corrections that our operators do. And it goes through a moderation pipeline, and we can validate and publish the data very, very quickly. Usability. It's all great to have great data, but only if you can get good access to it. So I talked a little bit about the single box, but I want to talk a lot more about it because it's I think, one of the biggest challenges we have, and a lot of our engineers spend a huge amount of time figuring out what to do with your query. We have, a geocoding database. That's easy. Figuring out how to parse it out and make the best answer for users' intended question is very hard. We have to deal with different languages, right to left to right, Arabic, Chinese, Japanese, all very difficult. We have to deal with partial addresses, city name, street name, without a state or anything else. We can guess based on proximity. Searching for categories, searching for specific navigation businesses, finding those. Also being able to turn on and off traffic and doing driving directions, all from the single box. The ability to take the user's action and, in as many cases as possible, get it right the first time is very powerful. In addition, we have autocomplete down there at the bottom. This provides not just guesses at what we think you want, but suggestions of different things you can do with Google Maps today. And some of these features, we have them in the API, but Thor is going to tell you a lot more in the near future. Another part of usability is giving good performance and delivering. We announced recently 1 billion monthly active GeoMap services users. And to deliver that kind of service reliably, over the past 3 years, our tile servers have had greater than 4 nines reliability. We don't have scheduled downtime at Google, so that's 26 minutes a year. We have 1.6 million QPS peak tile serving right now, but we can probably go higher. All from 8 data centers, which give you low latency no matter where you are. However, that power allows us to do some really cool things. I told you before that one of our innovations in 2005 was to pre-render the map tiles, and that really greatly increased the speed. But over time, we've had some crazy ideas where we could actually render the map tiles on demand. And doing so actually gave us great improvements. Now, you may not have noticed because they're still raster map tiles when they come to you, but the fact is that we render everything on demand. So road traffic is a good example. Most people who do road traffic will do an overlay raster on top of the map data. And what that means is that it obscures some part of the map. We're able to actually bake the road data into the map tile correctly layered under the road labels. Better user experience. But that's just one small thing. We have several more. Maps in your language, translated tiles. When you ask for map data, we'll give it to you the best we can based on who you are. In the API, we have styled maps, and many of you are familiar with this, the ability to render specific styles and match your website, match nighttime needs, whatever it takes. But the biggest thing, and really the reason that drove us to do it, was the ability to publish map fixes instantly. And so once the moderators approved an edit, you'll see these edits go live within 5 minutes or less worldwide. And so that ability is what makes us able to turn and correct maps and produce maps in new countries very, very quickly. So we have 800,000 developers or more working in Google Maps API today. And the amazing things they've achieved, amazing things you've achieved, have given us all sorts of inspiration. But we're continuing to grow. We think Google Maps API is a critical part of our map service. And even today, year over year, it's greatly increasing in use. So counter-argument to some reports you might have read. But with that, I would like to introduce Thor Mitchell, who's going to talk about new features in Google Maps API. Thanks.
Thank you. Okay, good afternoon, everybody. As Brian said, my name is Thor Mitchell. I'm a product manager based in the Sydney office, focused on the Google Maps API and the Google Places API. Today, I'm going to give you a preview of some of the new features that we're bringing to these APIs for you here at I/O this year. Before we go into that, though, I just want to emphasize how much of what I'm about to show you has been driven by you. Your feedback is very important to us, and we connect with developers in many different ways, such as through sponsor tag on Stack Overflow, through events like this, and through our regular office hours hangouts. One of the most useful tools we have for understanding your needs is our issue tracker. So if you're not familiar with our issue tracker, this is a site you can go to tell us the features that you're looking for and express interest in ideas that others have added for features you'd like to see. And as you'll see as we go through, we take this very seriously. And if there's one takeaway from this session I'd like you to have, is to make good use of this tool. So let's begin with the Places API. Now, if you were with us at I/O last year, you may recall that I think possibly in this very room at this very time, we announced the broad availability of the Google Places API. Now, if you're not familiar with the Google Places API, it's our developer offering for access to our worldwide corpus of local business listings, points of interest, and landmark data. At its heart, the Places API is very simple. You provide us with our location, you provide us with a radius, and we'll give you back the 20 best places nearby. And to tailor these results to your specific application, you can filter based on one of over 100 globally consistent high-level categories, such as restaurants. You can also provide specific keywords to focus in on particular types of business, such as a cuisine or a particular type of clothes store or such like. Another feature of the Places API that we launched last year is autocomplete. Now, Brian's touched on this briefly already, but this essentially brings that type-ahead search functionality that you see on Google Maps into your applications. And autocomplete is particularly useful when dealing with those infuriating multi-field address forms that litter the internet. There's no reason you should have to force your users to enter their details in all these different fields over and over again. You can give them one single text field, they can just type, we will complete the address for them, and then we'll give you the structured address components that your application needs. So it's such a better user experience. Once you have used this, every site you come across that asks you to enter an address that doesn't use it just drives you crazy. Okay, so there's nothing new here. What is new? Well, as I mentioned earlier, one of the things that we take very seriously is your feedback. And when we took a look at the issue tracker for the Places API, there's one issue that has been way out in front in terms of the amount of requests we've had for it since the day we launched. That's access to Google reviews. So I'm happy to say that starting today, when you use the Places API to get detailed information about a business, we'll return to you the top 5 reviews for that place, as shown on Google Plus Local. So if you take a look at Google Plus Local and look at a specific review, you'll notice that it's made up of certain elements. There's the text of the review, there's the scores that the reviewer gave, and there's also information about who submitted that review if they have a public Google Plus profile. All of this information is now returned in the Places API. You may also know that if you log into Google Plus Local as a signed-in Google Plus user, there's some additional information available to you that's provided by Zagat. This includes scores across 3 aspects of the business, and those aspects vary depending on the class of business. So for a restaurant, it's decor, food, and service. There's also the editorial review, which is a human-crafted summary of the best reviews that we've received for that business. Now, we're working on a new option for our Maps for Business customers that will allow you to get access to this Zagat content as well. So if that's something that might be interesting to you, please do contact the Maps for Business sales team. Okay, so up to now, the Places API has been really very focused on mobile location-based apps. And these apps have one big advantage, which is they have access to a fine-grained location signal for the user based on GPS. And that allows us to give you an easy way of searching near the user. However, we recognize there are many use cases for local data which would benefit more from the sort of single one-box usability experience that Brian mentioned. And so we're bringing that to the Places API today. So now you can let your users express their searches just in simple text in any way they like, and we will interpret it for you. You can see that this could be a what-where query. This could be a query that just contains a category, and then we use the map to infer the location. But also, it's just a single address, or a single business. So it's a very flexible model. And your users can just say what they're looking for. You all know this, you're familiar with it from Google Maps, but we're bringing that into the API as well. We're also extending the existing autocomplete functionality to be able to suggest possible queries as you type, as well as the places that it suggests today. Okay, so that's all I'm going to cover on the Places API for this morning. However, it's not the end of the announcements we have for the Places API. And if you'd like to hear more, I recommend this session, Building a Business Around the Google Places API, that is happening next door towards the end of today. Marcelo is our engineering lead for the Places API, and Andreas manages our developer relations team for Maps. Okay, so now we will move on to the Maps API. Now, as some of you may know, the Maps API has been through a significant transition in the last few years. Back in 2009 at Google I/O, we introduced the version 3 of the Google Maps API, and a year later, it became our primary Google Maps API. And since then, we've been working to bring over features from V2 that people value into Maps API V3. And along the way, we've also attempted to make improvements where we can, and also bring new features. And there are many advantages to Maps API V3 as a result. Now, we reached a significant milestone earlier this year when we moved the last of the V2 features that we want to bring into V3 over, which means that if you're continuing to maintain or develop a V2 application, now really is the time to go and make the migration, especially as the end of the V2 deprecation period is now less than a year away. Okay, so what's new in Maps? Well, when we sat down and tried to think about how should we figure out what we should develop that would be new for you, we really realized there were two key questions that had to be answered. Firstly, what do developers want? What is it you're looking for in this service? What can we offer you that will help you? What do you need? Secondly, what can we do that would be awesome? What could we do that would be new, innovative, maybe not something you thought of, but something that would have broad appeal, something that would really increase the capabilities of the Maps API to meet its goals? And in doing that, we had to answer questions like, what is the Maps API for? What is its purpose? So I'm going to touch on one feature from each of these two categories this morning. Firstly, what do developers want? Well, once again, this is easy for us to determine. We simply go to the issue tracker and we take a look. And if you look at the issue tracker for the Maps API, you discover that one feature has, across all of our APIs, has been way out in front for a couple of years now, which is why I'm very happy to say that today we're bringing Google Transit to the Maps API. So we're introducing Transit to the Maps API in two ways. Firstly, we are adding the transit layer, which allows you to visualize the transit network for a city on top of your map. Secondly, we're adding support for transit as a travel mode in the Directions API and the Directions service, so you can route across public transport. Okay, so that's something that developers want. What about something new? So when we were thinking about something new, as I mentioned, we asked ourselves, what is the goal of the Maps API? And really, the Maps API, unlike, say, Google Maps, which is about navigation, it's about finding businesses, it's about understanding the world around you, the Maps API is about you. It's about your data, it's about your stories, it's about the message you want to get across. And so we wanted to find ways to help you do more flexible and interesting visualizations of your data in the Maps API. But once again, the inspiration for where we ended up actually started with our issue tracker. Because we saw this. Polylines with arrows. It seems easy. I mean, you take an arrow, you stick a triangle on the end. How hard can it be? Well, it turns out there's some complexities to this. You see, what happens if you move the map? Our maps are panable, they're draggable, you can zoom in, you can zoom out. That arrowhead soon goes out of view, and then you lose all that directional context. And what about the shape of the arrowhead? I mean, there are a lot of different ways you can draw an arrowhead. This is just a small sample of the 130 different arrowheads that are in the Unicode spec. And we didn't think necessarily that trying to give you a canned set was sufficient. We wanted to give you more flexibility. So we figured maybe it'd be better if we let you define the shape of the arrowhead yourself. But if we're going to let you define the shape of the arrowhead, why stop at arrowheads? So today we're introducing a simple, simple but powerful new concept into the Maps API. And we call it symbols. A symbol is an icon, much like an existing marker image that you might use today. But it's defined as a vector, and it's rendered by the browser in the client. The consequence of this is that, firstly, as a vector, it can be resized easily without any loss in quality. And secondly, that you can control in your application how it's styled, its stroke, its fill, its opacity, etc. Critically, not only can you control how it's styled, you can change how it's styled dynamically. So to give you an example of the value of this, I'd like to show you a Maps application that uses symbols as a marker rather than the existing marker images. A few years ago, Walmart released a data set that included a list of all of their stores and the dates at which those stores opened. So what we're doing here is we're simply visualizing that expansion of the Walmart chain over time in the US. Now you can see that we represent each store with a small red dot. That's a symbol. We also use another circle around the dot to indicate when the store is opened. That's another symbol, but a symbol that we grow, and we change the opacity to fade it away over time. What you may also notice is that we're not done with the dots once we've plotted them. As time passes, we change the color to illustrate how long that store's been opened. And so you can see visually, not just as an animation, but through color, how the distribution of stores across the US occurred over time. Just let it run because it's quite pretty. OK, so this is an example of using a symbol as a marker. But what about those arrowheads? Isn't that where we started? So as well as just using symbols as markers, you can also use symbols to decorate polylines. So you can see here I'm using drawing tools, and this particular line has an arrowhead attached to it. I can also configure the arrowheads to be repeated along the line to address the problems I mentioned earlier. And there's a couple of different ways of doing this. In this case, I've set it so that the arrowhead density remains constant as you zoom in and out. Of course, not just arrowheads. You can use any symbol to decorate a polyline in this way. Here's a few examples of the sort of symbols that you might use. And what you'll notice is that the symbol styling is independent of the polyline styling that it's attached to, which raises an interesting possibility, because we can just hide the polyline. And then we get to implement another feature developers have asked us for, dotted lines and dashed lines. Now, these lines are straight just because it fitted neatly on the slide, but the symbols will follow the shape of your line, even if the line is geodesic. What's interesting is that in much the same way that I said to you that the symbol properties relating to the style of the symbol can be dynamically modified by your application, so too can the rules on how the symbols are rendered on the line, or where they're rendered on the line. Which means you can do things like this. Now, when I saw this, I got quite excited. And I reached out to a colleague of mine who works on our flight search team, and I said, do you have any good data on flights? He said, we have all the data on flights. And he sent me a file that contained the schedule for every single commercial flight on the planet today, from every airport to every airport, what time it leaves, what time it arrives, what type of plane is, and whether they serve food. So using that and combining it with the Maps API support for geodesic polylines and symbols, I was able to build this. This demo shows, or will show, I hope, in a second. Come on. Oh, going backwards for some reason. Here we go. This demo shows every arrival and departure from San Francisco Airport happening today. Each of these, you can see the curfew lifts at 6 and boom. Every single plane on this map is simply a symbol attached to a geodesic polyline that runs from the origin to the destination. I don't have to worry about how to calculate the location of these planes. I simply set a percentage offset along that polyline based on the difference between the departure and arrival time. The Maps API does everything else for me. We even go as far as calculating these distances, these percentage distances along geodesics in meters to make sure that these positions are accurate. So this is, I think, as I say, a simple concept that really powers up our data visualization capabilities. But it's not the only data visualization feature that we're launching at I/O today. However, oh, this really is going backwards now. Oh, yeah, I know it's nice, but we've seen it. However, I sadly am out of time, so I recommend you attend our next session, which is right next door, immediately after this one, on spatial data visualization. And with that, I'd like to hand over to my colleague Dylan, who's going to talk a little bit about our enterprise efforts.
Thank you.
Cheers.
Hello, my name is Dylan Lorimer, and I'm a product manager at Google on the enterprise geospatial team. And our mission on that team is to make it very simple, to make it incredibly simple for any business or government or enterprise organization to use our geospatial technology in the context of their everyday kind of business decision making. And we see all kinds of really interesting, varied use cases of our technologies. Everything from the prototypical kind of store locator on the web to fleet tracking and asset tracking solutions, disaster response, kind of humanitarian response maps that serve a great purpose, in this world. We have organizations managing their entire catalog now of GIS data or geospatial data in our cloud. We see maps embedded in planes, maps embedded in all kinds of vehicles, and then all sorts of third-party software vendors embedding our maps and our services in their products. Our goal is to make this all possible on the enterprise geospatial team. And really the common thread across these use cases is data. Businesses and governments tend to want to take their own mapping data and put it on top of Google Maps or bring it into Google Earth or distribute it to mobile devices. And these businesses and governments tend to have their own types of data, really specific to kind of what they do. Sometimes different data than what Google would publish on its base map. So for instance, private floor plan data or data pertaining to the infrastructure for their jurisdiction might be more current imagery or kind of false color or derived imagery data sets. Whatever it is, it's really specific to kind of how they conduct their business day to day. And historically, it's actually really difficult we found, for governments and businesses to be able to take that data and actually put it on the map. It's required a costly investment in on-premise hardware, expensive software licenses, dedicated administration, specialists to kind of manage the data. It just hasn't been that easy. Google, on the other hand, we've built a lot of great infrastructure over the years. Brian kind of talked about all of it, but great infrastructure, really in support of our consumer mission for Google Earth and Google Maps, to take all the relevant geospatial data of the world and provide it to our consumer users to kind of meet and surpass their expectation for the best, most authoritative data. We've built this great infrastructure, and we recognize that businesses and governments could benefit from it. Why couldn't we provide them with access to this cloud platform, essentially, or these tools to kind of process their own data? And so we did that. We launched Google Maps Engine earlier this year, really late last year, earlier this year, and that's Google's Geo Cloud Platform, enabling businesses and governments and anyone to upload their mapping data to Google's cloud, whether it be a spreadsheet containing their store locations, could be some shape files or other data sets pertaining to kind of the base map, could be terabytes of imagery. Whatever it is, upload it to Google's cloud, securely manage it in our cloud, and then get access to our processing technology to build maps and build layers with it, and then publish those to your users, who could access it through simple-to-use desktop applications like Google Earth Client, or a Google Maps-like interface, or Google Earth on mobile devices, or also expose it to developers to kind of embed in their own third-party products. That's Google Maps Engine today. We launched it as an enterprise product. It still is an enterprise-only product, and we do intend later in the year to provide for like an online trial that folks can try out online without having to speak to our sales team. And we're really thrilled with the use to date. We're actually now serving, this is in addition to what Google serves on its base map, we're now serving through Maps Engine almost 170 terabytes of customers' own data. This is data they've uploaded, or raster data. This is raster data they've uploaded to Maps Engine, and they're serving securely to their users, whether it's their customers, their employees, their constituents, or the public at large. Whoever it is, it's their data in Google's cloud served out through our technology. Almost 3 billion features, vector features of data that are hosted in our cloud and rendered into tiles kind of on demand for use in their mapping applications. And we're now seeing greater than 1,000 private maps from our customers published to their own users. So we're really thrilled with kind of the usage to date. And also really excited about what we have in store. So for the past kind of 4 or 6 months since launch, we've really been focused on a few key areas of innovation based largely on kind of customer feedback and what we're excited to bring to market. Rich API to the platform is by and large kind of the thing we've heard that most of our customers have requested from day one. So we're going to talk a little bit about APIs today, and then also some next generation ways to visualize the data, sort of in line with what Thor had demonstrated with the Maps API. By far, the number one feature request from our customers has been programmatic access to the Maps engine platform. Our users want to be able to programmatically upload data, download data, build maps, process imagery, publish maps, query data sets, append features, kind of have a full set of programmatic capabilities to our platform. And so today I'm delighted to announce that a little bit later this year, pretty soon, we're going to release to all Maps engine customers in sort of a trusted testing capacity this first release of the APIs. And the APIs really offer kind of two broad categories of capability. Programmatic kind of data upload, data query, the ability to find data sets available to you as a user, the ability to build layers and so forth. And then also kind of vector CRUD type operations, the sort of queries, appends, edits, and inserts into individual vector data sets. So for instance, if you had a set of store locations, you could kind of query those stores to find stores that were open between 10 a.m. and 9 p.m. that had a handicap ramp, for instance. So we're excited about these APIs. They'll be available soon to our Maps engine customers. And I thought it would be helpful to actually make this a little more concrete, to actually talk to an existing application built on Maps engine. So this is by one of our partners in Vista. They build a utilities management mapping application that they provide to cities to help them get an understanding of what's going on below their city streets. And the capabilities here that sort of articulate what the APIs will provide is that users log in based on their identity. They get access to different layers. You actually see a premium image being distributed from GeoEye, who also use Maps engine, brought right into the application. Users can restyle layers based on mouse clicks and events. They can get a tabular view of the attributes, based on other kinds of queries, and then even do more advanced things like buffer lines or do intersections. So this is just a good example of the sort of prototypical application that we expect a lot of folks to build on these Maps engine APIs. The other area we've been focused on is sort of this next generation of visualization of your data in the cloud. Thor spoke at length about the opportunity with modern browser technology for client-side rendering of data, of Google's data. And that's also, of course, possible with customers' data stored in Maps engine. So I'm going to jump into a video here, but what you're going to see is that polygons for the world, for countries of the world, is that going? Polygons for countries of the world are sent to the browser. The developer in JavaScript has sort of structured access to them, and they can choose how to render them. In this case, based on temporal characteristics, they can style them a certain way and kind of create a time series. And this is just a really basic example of what's possible, but really anything's possible when kind of on the client side you have this rich structured access to the data. So this will also be turned on for Maps engine customers for their data later in the year. Great. Not all customers have their own data, but many of our customers have a big thirst and appetite for additional data. And so, for these other data types out there, beyond those that Google publishes to our base map, we're really excited to have announced that we're relaunching the Google Earth Gallery. We relaunched this last week. And this is sort of Google's place to organize and surface all the rest of the world's geospatial data. So the data that doesn't appear in our base map, these are kind of additional layers that maybe don't make sense to include in our base map for typical consumer users. We intend to surface kind of all the world's authoritative, rest of the world's authoritative public data in the Google Earth Gallery. And what's so cool about it is it's built on Maps engine. And so all the maps in it that you discover are accessible and served kind of via all these Maps engine capabilities. So you can easily view it in Google Earth. You can bring it into a Google Maps-like front end. You can actually get embed code to stick it right in your blog or your website. And then you can also get access to the JavaScript to actually take those layers and those maps and put them right in your own mapping application. So we're sort of enabling developers in this case to get access to all this great additional layers and bring it right into their maps. And if you want to learn more about Google Maps Engine and the gallery, you can go to a session tomorrow put on by some of our sales engineers. Great. Not all data is static, though, right? The gallery Maps Engine is largely around kind of contextual layers that you style and that you can view in the context of a map. Maybe update them periodically through APIs, but there's just tremendous amounts of data in this world, geolocated data that's dynamic in nature. For instance, the locations of people or teams of people, or animals or packages or whatever it may be. There's just a lot of dynamic data out there. And the IDC actually reports that they anticipate by 2015, over 1.5 billion employees in the world, in the global workforce, will be mobile. They won't be at a desk, they'll be out in the field going to job sites. And there's just no easy way today to manage that, right? Like, it takes a lot of effort to build a mobile application and have a server that can take those locations and kind of render them to users and to administrators. And there's just no simple way for organizations to manage this. And so earlier this week, or last week, we were really delighted to announce Google Maps Coordinate, which is an out-of-the-box, simple solution for businesses to equip their mobile workforce with an application on their phones and to provide the workforce with tools and capabilities to capture data in the field, to share that data with the central organization, and for that central organization to kind of manage those assets and dispatch them to job sites and other locations. And you can learn more about it at maps.google.com/coordinate. Coordinate is actually built, though, on top of a new API that was kind of built from the ground up to really support this notion of rich, comprehensive asset tracking applications built entirely out of Google's cloud. Historically, developers building asset tracking applications have had to have their own database and go to a lot of effort, essentially, to store the locations of assets in the world and kind of render them on a map. And so with the Google Maps Tracks API, this is an opportunity for us to really rethink what a perfect asset tracking API could be for our developers. And it was purpose-built from the ground up to store the locations of your dynamic assets in the world, to provide for query capabilities on them, store their history, provide some visualization capabilities, and just otherwise let you manage those assets in Google's cloud. You can group them into collections. You can define geofences and be alerted when they enter or exit those areas. And this is going to launch to trusted testers right about now and will be available later in the year. So with that said, I wanted to pass the mic here to Peter Birch, who's going to talk about Google Earth and the future of 3D. This doesn't work very well.
Thanks, Dylan. And as you can see, we also have a great talk coming up to learn more about our enterprise solutions. All right. So those of you who actually got a chance to see our event a few weeks ago, we talked about a lot of great new things, including the new next dimension of Google Maps. And in that, I actually talked to you about coming soon on Google Earth for Android and iOS. And just to get straight to the punchline, today I'm proud to announce that this is available today in the market on Android. And will be coming very soon for iPhone as well, and iPad.
Throughout history, we've pushed boundaries to expand our view of the world. Today, a new frontier is at our fingertips. Introducing a new way to soar above your favorite cities in 3D. With the tour guide, exploring the world has never been easier. Take flight in Google Earth on your mobile device.
Great. And with that, we are one second. All right. So here we are. This is Google Earth with the latest version, 7.0, that's in the market today. And let's just dive right in. Now, one of the things that we've always had with Google Earth is that, with a lot of our Google products like Google Search and Google Maps, we want to help people find information. And in Google Maps, we want to help people find their way. Well, with Google Earth, we really want to get people lost, right? We really want you to go out in the world and explore, because that's really what the wonder of the world is, and that's what we try to bring to our users. So with that, we've also introduced this fantastic new feature that we call the tour guide. And what this is actually, for any given view, I can just open it up. It will give me a list of locations in the current view that might be of interest to me. So let's take a look and see what we got here. So let's, for example, click in on the Massachusetts State House. And then again, here you can see some useful information showing up on the screen. And it's actually taking us on a little bit of a tour here. And I can close that. And let's go check out Boston Common. So today we have approximately a dozen metropolitan areas that are going to be live, which include pretty much all the San Francisco Bay Area. We have Boston, we have Rome, we have Tampa, we have Charlotte, we have Brian's favorite place, Lawrence, Kansas. We have Portland. That's just a start. By the end of this year, we expect to have coverage for over 300 million people, and that's not the end. We're just going to keep growing from there. Because we're really excited about bringing this new 3D image technology to users around the world. And if you want to learn more about this technology, we have a blog post out on the Google Lat Long blog right now. And also, if you go back and look at our next dimension of Google Maps, you can see some more information about some of this fantastic technology. And with that, I'd like to bring up Brian McClendon to wrap us up.
Thank you. Thank you very much, Peter. Am I on now? Testing.
Yeah.
So I wanted to thank Peter. The Geo team at Google has been working extremely hard on many projects. Today is one of the big days at Google where we get to launch many things that have been in the works for a long time. But the amount of work that our team has put in to make this and all the other launches you've heard about both here and on the main stage possible has been amazing. I think we have the strongest engineering team working on maps today, and I'm extremely proud of them. To add to that, he announced that we have the 3D imagery available on Google Earth in the store today. We also did just right now launch GMM 6.9, which has the offline maps that was also talked about. So I think we delivered on those two major launches. And I would like to get the slides back, coming momentarily. And we'll talk about the rest of the Geo track, because we have a lot of teams that want to talk to you in much more depth about what we've done and help you understand how to use some of the features. The animated symbols is just incredible. I think from a programmer's perspective, I'm so excited about using that because it allows you to visualize large amounts of data. So so offline maps available. And the last thing I want to say is, you know, we're trying to reduce all the dragons. Okay, it's my fault. We're trying to reduce all the dragons, but there is one last dragon that probably, you know, we won't take out. And so I think the team in Japan who did the April Fool's joke, it was incredible. Getting Google Maps in 8-bit was one of the most fun things I think we've had inside Google in a long time. So with that, I'd like to say thank you very much, and you know, go on with the rest of Google I/O. Thank you.